Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last two lectures we had discussed various aspects about this exploratory data analysis, and we have understood now that what type of data we are going to collect, how are we going to collect, what are the different aspects. So now from today we will assume that we have got a data set. And now what are the different tools which we would like to apply on those data sets is the matter which we are going to discuss from today and all the lectures in future. So now if you try to see whenever the data comes to you, what would you like to know? And particularly nowadays when we are talking about data science, the data is coming automatically through various machines. You can imagine that how many people are accessing Google Maps at the same time around the world. How many people are accessing the shopping website, which are the popular websites across the country? Many. How many people are driving the car at a given time in the entire country? This is very large. Earlier, when we used to collect the data manually, then we used to have a very small data set. But now with the advent of new machines, new tools, this data is coming automatically to us. So the data size is very huge. Just to give you an idea, you can imagine that the room in which you are sitting, suppose the data is written on each and every wall, on the roof, on the floor, in a font size of say 4 or 5. Can you really understand anything from the data? Very difficult. And you can complicate it if you believe that the data is continuously supplied to you. What would you do with that data? So now you have to think, what are the different types of information you would like to have so that you can understand what data is trying to explain you? What information does the data have? So one of the basic objective is that when the data is coming continuously, we want to study that what is the behavior of the data. And in order to do that thing, there can be different questions in which anybody would be interested. For example, the owner of Google Maps might be interested in knowing that whether this Google Map is used more by the younger people or by the older people. Or the shopping website might be interested in knowing that whether the younger people are accessing the site more than the older people, or what is the preferred mode of payment, whether this is credit card, debit card, cash on delivery or UPI, etc. And you can see that when the millions of customers are accessing the site at the same time, how they are going to count it? Well, you can ask me that how this data is available to them. Is how do they know that whether a younger person is accessing the website or an older person is accessing the website? You know that whenever you are trying to do any shopping on any website, you always try to create a profile in which they collect different type of information like as your name, address, age, etc. So from that information, they can very easily find whether the person with that login ID who is accessing the website is younger or older. Well, that's a different aspect that I'm not discussing that at your home. You have created the website in your name and your grandfather is doing the shopping using your login ID. I'm not considering those ideas, so don't think in that way, please. Right. So now if you try to see what would you like to have, you would like to have that, for example, during the festival time, how many young people are accessing the website and what do they want? They want a jeans or they want a pajama kurta? So now you want to compile and condense such information very quickly. So the first very common information which everybody wants is the information on the condensed data that somebody is accessing, whether you want to find out the number of male, female persons, or whether you want to know that those persons whose ages are less than 20 years or say more than 20 years, etc. So now how to get it? So for that we have the concept of here frequency distribution, in which we try to compile the data in a particular way such that it gives us the reasonable information which is useful for us. So now in this lecture and in the next two more lectures, I will be talking about the frequency distribution. What are the different definitions, what are the different concepts, and how are you going to create this frequency distribution for discrete data, for continuous data, for qualitative data, for quantitative data, etc. And then once you have the data, how are you going to create or condense the information using the R software? So these are the objectives which I am going to cover in this lecture and in the next two lectures. So with this objective, let us begin our lecture and try to understand this concept of frequency distribution. So now we attempt to understand the concept of classification of data. What is this classification of data concept? The process of arranging the data into groups or classes according to their resemblance and similarity. This is the classification of data process. For example, if you are the owner of a shopping website and if you want to know that what are the age groups in which people are accessing the website and what commodities they want to purchase, then you can create the groups like say 10 to 15 years, 15 to 20 years, 20 to 30 years and so on. And then you can count that how many people or say how many persons in that age group have accessed the website, and then you can further see that what was their interest, whether they want to shop for electronic gadgets or for clothing or something like this. So this is what I mean by the word resemblance and similarity. Now when we are collecting the information on the data, then as we have discussed earlier, the data can be of a different type. That can be a discrete data, that can be an attribute, or that can be a continuous data. So if you try to see, the variable takes values at particular points, then the data is will be considered as discrete data. And when we are trying to collect the data on categorical variable which are indicating the presence or absence of a characteristic, then it is the attribute data. For example, if there is a taste, sweet, salty and neutral, then there are three categories in which we would like to give some indicator values like 1, 2, 3. So if in the salt is getting 1, that means if there is number 2 which is indicating the sweet, that means 2 is indicating that there is no salt or neutral. So this is only indicating the presence or absence of the characteristic. For example, if I say gender, male, female and transgender, I can give the category 1, 2, 3. Right. So you are simply trying to presence or absence of a characteristic in a particular group. Then in the case of continuous data, variable takes values in an interval. Right. For example, if I say the time taken by person in traveling 1 kilometer, right. So that can be say this 15 minutes 1 second, or 15 minutes 1.11 second and so on, right. So for example, if I say that if I want to find the number of tomatoes in a basket, which can be something like 25, 27, 25, 26 and so on, then this is a discrete variable. And similarly, if I roll a die and I observe the values on the top, so these values can be 1, 2, 3, 4, 5 or 6. So this is an attribute. And similarly, if I try to find out the time to run 100 meters, that can be 2.1 minute, 3.2 minute, 2.2 minute, etc. So this is a continuous variable. So that we already had discussed in the last lecture. Now we have to use it. So what are the functions of classification? Why do we do it? The first advantage is that it really condenses the data. So we want to condense the data so that we can get a condensed information which I can really understand. Yeah, for example, if I say if there are 10,000 students in a college, I want to know what are their ages. But if I tell you the 10,000 values of their ages, you will not be able to understand much. But if I tell you the average age is about 20 years, then you will understand it much better. And the condensation of the data will give us the outcomes, which will facilitate the comparison. Suppose if I say there are 2 colleges in a city, and in one college the average age of the student is 20 years, or if I say that the time taken by the students in completing the degree in the first college is 4 years, and in the second college it is 6 years. So what does this mean? That means on an average the students in the second college are taking more time to complete their degree, and yeah, that may give a different type of information whether the college is good or bad and so on. We can take such type of decision. This also helps in studying the relationship, what they are existing in the data. For example, if I collect the data on day temperature and water consumption during the summer time, then if you see the temperature is increasing, then the consumption of water in the city is also increasing. So that will indicate that, okay, there is a relationship between the temperature and the consumption of water. And once we have all this data, then it is easier for us to employ statistical calculation, statistical tools and statistical treatment to the data so that we can get a fruitful outcome, right? Now we come to the concept of absolute frequency and relative frequency. So I think instead of taking the formal definition, let me try to take a very simple example by which I will try to introduce the concept of absolute and relative frequencies. Suppose I say that there are 10 persons who have participated in a test and their results were declared in 2 categories, as they have passed or they have failed. It is only a qualifying exam. And suppose that data is given as P, F, P, F, F and so on. So P is indicating pass, F is indicating fail. Now you can imagine that this type of data is suppose in millions and billions. Can you take out any fruitful information from here? It is very difficult. Well, I am taking here a very simple and small data so that you can view from your eyes and you can get convinced that whatever information you are getting from this data, that is really condensing the data and the statistical conclusion is correct. Once you are convinced for the small set of data, then even if you try to take a much bigger set of data, you can be confident that whatever you have done is correct. Right. So now in order to understand this data, what we can do, we can define here 2 categories, and we try to define the category as a small a1 and a small a2. So which are referring, a1 is referring to pass category and a2 is referring to fail categories. Right. So if you try to see here that how many persons are there who have actually passed and who have actually failed. So if I try to count the number of passed students, 1, 2, 3, 4, 5 and 6. So in the first category there are 6 persons, or there are 6 persons who have passed the examination. So this number I try to denote as N1 is equal to 6. And similarly, if I try to take here that how many persons have failed. So let me count it here. 1, 2, 3, 4. So out of 10 persons, there are 4 persons who have actually failed, or there are 4 persons in the category A2. So this number is denoted here as N2 is equal to 4. So this number of observations in a particular category is called as absolute frequency, right? So now you can imagine that if you have got millions and billions of observations, And suppose you classify the ages of those observations into, suppose, say this three groups, say young, middle age, and then older. You can define some limits, say less than 20 or less than 25 is younger, 25 to 50 it is middle age, more than 50 it is older, and so on. Then you can simply count out of those billions observation that how many people are there in that category. And then this will give you a condensed information to know that whether that what type of category is accessing the, for example, the website more, right? And but sometimes it gets difficult to understand the language or the interpretation of the data. Suppose if I say out of this 20 billion observation, okay, 10 billions are young, and say 2.5 millions are say older, and remaining are this. It becomes a little bit, say, difficult to understand, because you always want to know that out of how many observations these many people are there in the category. So the simple option is that we can find out the relative frequency. So we try to find out the relative frequency of class A1 and class A2 as follows, right? So we simply try to see that the total number of persons in the category 1 divided by the total number of persons in all the categories. So as we have denoted here by N1 and N2 the number of persons in categories 1 and 2. So N1 plus N2 is the total number of persons. So the relative frequency of the first class A1 is defined as, say, N1 upon N1 plus N2, and this is usually indicated by a small f1, lowercase f1. So you can see here now this number is 6 upon 10. Which is 0.6, which is 60%. And similarly, the relative frequency of the second class is the number of persons in the category 2 divided by the total number of persons. So this is indicated by here, say, lowercase f2, which is here 4 upon 10, which is 0.4, which is 40%. So now by looking at this number, you can very easily get convinced that 60% of the people are in category 1 who passed, and there are 40% persons in the category 2 who actually failed. So now if you try to translate to a data science situation that out of, say, there's 20 billion observation, if you say that, okay, there are 40% people in category 1, 35% in category 2, and remaining persons in category 3, then you will very easily understand. If I say that, okay, the number of young persons are 70% and the number of older persons are only 10%, then you can see that your website is more attractive to the younger persons, and you would try to modify it by doing something so that the elder persons also get attracted and they can get the things what they want. So this type of decisions can be taken very easily just by finding out the absolute and the relative frequency in the data, right? Okay, now the next question is this: how can you compile such information in the R software? Well, here it was a very simple case, so I could do it manually. But in R, there is the command which is called, here is a table, T-A-B-L-E, and then inside the parenthesis you give the data vector. Now you understand what is the data vector, means all the values which are combined with the operator C. Right. So this will create absolute frequency of the data vector. So I would say that we will now take a rule that when I write here small x in blue color Calibri font, that means it is our data vector, or or it can be other things also that I will say, but in general it is a data vector in which we have collected all the data. Now if I write here table x, table inside parenthesis x, then it will give us the absolute frequencies. And if I write here table x divided by the length of x, then it will give us the relative frequency. So you can see that it is very simple and straightforward thing. Right. So now if you try to see in the same example what I told you, the frequency table will look like that there are two categories, 1 and 2, and their absolute frequency, or say simply frequency, sometimes we say they are 6 and 4 respectively. Now I would like to get the same thing from the R software. So suppose I give this, actually if you try to see what I have given here, the category pass is given the number 1 and the category fail is given the number 2. Because you see this R software will only work on the numbers to count. So now I have given here this 1 to 1 2, for example, here I have given to the pass 1, fail to 2, pass to 1, fail to 2, and so on. And this data has been presented in the data vector result C1, 2, 1, 2, and so on. So this is your here data. Now if you try to see here table result, so you will see here this will come out to be like this. So first row is indicating the categories 1 and categories 2, and this 6 is indicating the absolute frequency of category 1, and this 4 is indicating the absolute frequency of category 2. So you can see here this was the same result what you have obtained earlier. So you can see that it is very easy to tabulate the data, but it will give you very important information also. Similarly, if you want to find out the relative frequency, you simply have to use the command table result and then divided by length of result. That means the total number of observation. So you can see here this will come out to be here like this. And yes, these are the categories 1 and 2, and this is the relative frequency 0.6 and 0.4. How it has been obtained? As you have seen that it was obtained as relative frequency. So 6 is the relative frequency of category 1 and 0.4 is the relative frequency of category 2. Right. So it is very easy actually, but before going into the details, let me try to show you these things on the R console, right, so that you get here more convinced. So you can see here that I have given the data here as a result. I have compiled it, and now if I say here that the table of result, right, you can see here it is here like this, and if you try to divide it by here length of here this result, then you will get here the relative frequency. So you can see here it is a very easy task. It is not difficult at all, and you can understand it very easily. Okay. So now just to convince you more, let me try to take here one more data set which we have used in the past in our lectures. This was the data set painters, and it was available in the built-in library MASS, M-A-S-S. So now I would, if you remember, this was a reasonably large data, but then definitely it is not comparable for a data set of data science. But my thing is this, that if I can convince you that it is that how are we going to obtain the result for this reasonably is a larger data set, then you will get more confidence that to apply such tool for the data science situations also. So let me try to upload the library by using the library command, library mass, and then you can see here that the columns names were their composition, drawing, color, expression, school. So these were the variable on which we have got the data, and if you try to recall, this data on composition, drawing, color and expression was numerical, and the data on school was categorical, A, B, C, D, E, F, G, H, right. So let me try to recall the data. So which I can do by calling the painters $school. So now you can see whatever we have learnt earlier, that is being actually used, and that was my idea. Now you will be comfortable in understanding. Even if I don't tell you what it is written, you can very easily understand it. Right. So now this is my here data, and now with this data I want to see that how many painters are in the categories A, B, C, D, E, F, G, H. So I can simply use here the command here table painters $school, and you can see here it is telling me that category A has 10 painters, category B has 6 painters, category C has 6 painters, category D has 10 painters, category E has 7, F has 4, G has 7, and H has 4 painters. And similarly, if you try to find out its relative frequency, then you can say here table of painters $school divided by length of the painters $school. Although the font size I have kept here very small because it was a longer row, and I wanted to present it exactly in the same way in which I get the data. So if you try to create here this data set, I will try to show you on the R console also, but it will like is here now. This will be the frequency table in which you can present this data, that is the school, frequency and relative frequency. So these are your absolute frequency which you had found here, and these are your here relative frequencies which you are indicating here. And if you just multiply these numbers by here 100, then you will get it in terms of percentage also, right. So you can see here it is a very simple thing actually. So now let me try to show you these things on the R console also. So first let me try to upload this data or this library. So you can see here this is library mass, and then yeah, I will get here the data here directly, or I can just go through with this directly here, this command here, table painters $school, and you will see here this is here the data. And if you want to see here the relative frequency, then it will once again be here like this. You can see here, right? So this is the relative frequency, and you can see here that if you try to simply multiply these values by here 100, what do you get here? You can see here now they are converted into 18.51, 11.11 and so on. So you can see here that 18.5% painters are in category A, 11.11 are in category 2 and so on. Right, so you can take fruitful conclusions which can help you in getting the information which was hidden inside the data, right? Otherwise, it was very difficult to find out from this data which you are writing here, that what is happening in this data. So this is the objective of this frequency distribution. Now there is one more concept of cumulative frequency actually. What is cumulative frequency? For example, if I try to show you with this example we have just considered. So now we have seen that in the same data set of 10 persons who participated in the test and were categorized into pass and fail. Now we have here two categories, 1 and 2, and their respective absolute frequencies are 6 and 4. Now suppose I want to know the answers of this type of question. What is the total frequency at any particular category which is less than k? Here, for example, there are two categories, category 1 and category 2. These are the possible values of k. So in order to answer these cases, these type of questions, we try to find out the cumulative frequency. So in order to find out the cumulative frequency, what we try to do, we form a table and we try to give the cumulative totals of the frequency proceeding from the lowest class of the table upwards. And this type of cumulative frequency is called as less than type. And the second type of frequencies, that we form a table and we give all the cumulative totals of the frequencies proceeding from the highest class of the table in the downwards direction. And this type of frequency is called as more than type frequency. So let me try to show you these concepts in this table. So now you remember that there are two categories here, 1 and 2, and whose respective frequencies are 6 and 4. Now what I try to do here is the following. First, I try to compute the cumulative frequency of less than type. So you can see here the first frequency here is 6. Now the second frequency I try to write down here 6 plus 4. Means both the frequency up to the second class, they are added together, and this is here 10. So I can say that the cumulative frequency of less than type for the class 2 is 10. And similarly, if I try to take here one more example, so in which I want to compute the cumulative frequency of more than type, then I have to go in the reverse direction. That in the first case, I have to get here both the frequencies together. 6 plus 4 is equal to 10. And then I will go to the second class where it is only here, the category here is 4. So what we are trying to do, whatever the process we had obtained in the case of less than type, we are going into the reverse way in the cumulative frequency for more than type. That first you write the cumulative frequency of class 2, and then you try to move upwards and then try to find out the cumulative total, which is 6 plus 4. So I am just trying to give you this example so that you can understand how are we going to do it. Anyway, your job is going to be done by the R software. Right. So for example, if you want to find out the cumulative frequency of the same data of result data, and then we have a command here, CUM/SUM, cumulative sum. This is the idea. So CUM/SUM, and inside the parentheses you have to give the data vector. This will give us the cumulative frequency of less than type. So you can see here, this was the data result, and then we had found the this tabular data, that is the absolute frequencies here 6 and 4. Now I try to operate here this cum sum, CUM/SUM, on the table result, right? This is what you have to keep in mind, that here that you are not going to use here directly the data vector, but you have to find out the tabulated result. And the idea is clear. Once you have to find out the absolute frequency, only then you can find out the cumulative frequency. That is why you have to be careful and you need to understand this basic concept, right? So, if you try to do it, you can see here the outcome here is like this. So, these are here categories 1 and 2 and their cumulative totals are 6 and 10 respectively, which is matching with the same outcome which you have done manually. You can see here the cumulative frequency of class 1 is 6 and class 2 is here 10, right. So, it is very simple and straightforward. And similarly, if you want to find out the cumulative relative frequency, then you know that it is straightforward. You simply have to divide the results only by the command length of the result, right. So, you can see here in the first line we have the data on result, and then we have found the relative frequency that you know how to find it out here. And now you are using here a command of CumSum, CUM with the table divided by length of the data vector. So, you can see here this outcome is coming out to be here like this, where these are the categories 1 and categories 2. The relative frequency of category 1 was actually 0.6 and the cumulative frequency of the category 2 here is 0.6 plus 0.4, which is here 1. So, you can see here this is matching with this cumulative frequency or cumulative relative frequency which you had found manually. So, you can see here it is not a very difficult thing actually, and same thing I can show you in the case of painters also. Then we will proceed to the R software. So, now you can see here this was our data set for the painters school variable, right. Now, and now you try to find out the absolute frequency by the command table painters $school, and then we try to find out the cumulative sum of this table command. So, you can see here now in the category A there are 10 painters, or there are 10 painters whose school was actually A. There are 16 painters whose schools were A and B. Similarly, there are 22 painters whose schools were A, B and C. Similarly, there are 32 painters whose schools were A, B, C and D. There are 39 painters whose schools are A, B, C, D, E. And similarly, there are 43 painters whose schools are A, B, C, D, E, F. And similarly, there are 50 painters whose schools are A, B, C, D, E, F and G. And there are 54 painters whose schools are A, B, C, D, E, F and GH, A to H, right. So, this is the type of information which you get from the cumulative frequency. In the earlier table, it was a very simple 2 categories. So, it was not so easy to explain, but here I can explain you very clearly. And similarly, if you want to find out the cumulative relative frequency, so you can see here I have found the relative frequency, and then I have found here the cum sum over this relative frequency, and here you are getting the value, right. So, better is that I try to show you here first, and then I will try to show it on the R console. So, you can see here that we have here these schools, and these are the absolute frequencies of the respective schools. Now, I am trying to find out here the cumulative frequencies which are of less than type. So, from here it comes here 10. Now, this here 10 and 6 they are added together and we get the, in the second case, then 10, 6 and 6 they are added and we get it here in the third school C, and similarly 10, 6, 6 and 10 they are added together and we get it here in the fourth class to get the cumulative frequency of school D, and so on. And similarly, if you want to go for the relative frequency, the same thing happens here. Here these are the relative frequencies, and then we are getting the cumulative frequency of the school A as this first value, and then for the second say school B, the cumulative frequency is 0.19 plus 0.11 like is here. And similarly on the same concept, the sum of first three relative frequencies will give me the cumulative frequency of the class C. That means there are these many 0.11 or say 11% people up to in the class A, B, and C, and so on. And the same interpretation can actually continue, right? And you can see here, this is the screenshot which now I will try to show you on the R console actually, right? So you can see here that we already had created the absolute frequency and relative frequency. So it is very easy for me to execute this command here. And you can see here that these are the cumulative frequency of the same data set. And similarly, if I try to take here the cumulative relative frequency, so I will just copy this command. And we already have found the relative frequencies you can see here. So if I try to find out here, this is the cumulative relative frequencies. And if you try to multiply it by 100, you can see here that these numbers are indicating that 18.51% painters are from school A, 29.62963% people are from schools A and B, 40.74074% painters are from the three schools A, B, C, and so on. So you can see here it is not very difficult to get the conclusions from such a data set. And yeah, now we conclude this lecture, and then I have given you an idea that how the concept of absolute frequency, relative frequency, and cumulative frequency are going to be helpful when our data is like in the categories. So you can see that if these categories, if you try to expand to and your data size is too big, then this condensed information will give you a very fruitful information, which will give you an overview of the information which is contained inside the data. Right. So now I will stop in this lecture, but I would request you that please try to take some examples. First, try to take a small data set, try to prepare yourself, and then try to do all this analysis, whatever I have told you here today, and then try to choose a bigger data set. You can find such a data set inside the R software also, which are not that big, but if you are working in some data science problem where the data size is huge, which are available on different websites, you can download that data and try to conduct this analysis and try to see that how much information you are getting into this. So you try to practice it, and I will see you in the next lecture when we will try to make the frequency table for continuous data. Till then, goodbye.